Welcome all. In this session we will discuss dispersion of light, rainbow, how rainbow can be formed, and how a ray of light, how light can be scattered during sunshine, during sunrise and during sunset, how the skies appear to be red and how the skies appear to be blue. That phenomena I will explain in this session. Initially we will see what is meant by dispersion of light. We know that when a ray of light incident on the prism, the ray of light can refract and get emerge. Similarly, when a ray of light, the beam of light, the narrow beam of light incident on the prism, the ray of light can split up into 7 constituent colors. This phenomena we are calling dispersion of light. When white light is allowed to fall on the prism, that white light can split up into 7 types of colors. That phenomena we are calling dispersion of light. And whatever the 7 types of colors obtained, the band of colors obtained, that we are calling spectrum of the light. See here, how dispersion of the light can take place, that we'll see. Look at it. I can take, this is principal section of the prism. This is one prism. So either you can take a small angle prism or thin prism, or you can take any prism. Look at me. This is principal section of the prism. Let us name, this name is nothing but BCD. BCD is nothing but prism. Now on this prism, we know 2 refracting surfaces are available. BC and BD are nothing but 2 refracting surfaces. Consider when a narrow beam of light incident on the prism. See here, a narrow beam means the narrow beam of white light incident on the prism. See here, I can take, this is nothing but narrow beam of light incident on the prism. Say this light, what we are calling, this light we are calling white light. Right, white light. When white light incident on the prism, the white light can split up into 7 types of colors. 7 types of colors mean, so actually this is one type of light and this is second type of light. See here, this light I can call red light and this light I can call violet light. In between red and violet, so many types of colors are available that I can take in the form of Vibzior. In the form of Vibzior, like this. 7 types of, the band of 7 colors are obtained when white light allowed to fall on the prism. This phenomena we are calling dispersion. See here, I can take here 7 types of colors are there. What we are calling? One is nothing but violet, indigo, blue, green, yellow and orange and red. 7 types of colors are there. When white light is allowed to fall on the prism, the red light has the least deviated and violet light is most deviated. Red light is least deviated and violet light is most deviated. This band of 7 colors, this we can call spectrum. This I can call spectrum. Here, this white light has a minimum wavelength and red light has highest wavelength. Question is, why red light is least deviated and violet light is most deviated? Look at me. Initially, we can define the angle of deviation. See here. In absence of this prism, how this ray of light can travel? This ray of light can travel like this. Are you following me this? Then angle between incident ray and this emergent ray, this we are calling angle of deviation. This I can call angle of deviation. Right on this. See here, this is nothing but angle of deviation produced by what color? This I can call red color. And what about this one? Angle of deviation produced by what color? This I can call violet color. Then how deviation depends? Red light get least deviated, violet light has most deviated. Look at me. We know deviation produced by thin prism. How it is? Deviation produced by thin prism is equal to what value? Delta is equal to n minus 1 into what value? A. This already obtained in the last class. See here. N is nothing but refractive index and A is nothing but angle of prism. This deviation mainly depends on refractive index. See here how it is. The deviation mainly depends on refractive index, that is a constant n minus 1 and again refractive index inversely proportional to wavelength. Inversely proportional to wavelength. See here. We know that this violet light has a minimum wavelength and red light has a highest wavelength. Are you following me? See here. If the case more the refractive index, more the deviation, lesser the refractive index, lesser the deviation. Remember this point. Now, out of 7 colors, this red color has the highest wavelength. I mean longer wavelength, highest wavelength. Highest of wavelength, then what is refractive index? Refractive index must be what value? Low. Wherever refractive index is very low, then what about deviation? Deviation will be low. I mean, red color has the highest wavelength, due to that it has lower refractive index. Due to lower refractive index, it has minimum deviation. On other hand, white light and violet light having a minimum wavelength and the highest refractive index. Due to highest refractive index, it has a more angle of deviation. So that red light getting least deviated and violet light getting most deviated. Now, when dispersion phenomena takes place, I mean splitting of white light into 7 constituent color, that we are calling dispersion of the light. During dispersion of the light, I can define 3 physical quantities. One we are calling angular dispersion, mean deviation and dispersive power, that we will see here. During dispersion of light, mainly we are defining 3 physical quantity. One we are calling angular dispersion, angular dispersion, angular dispersion. Second one is mean deviation, mean deviation, and last one is dispersive power. Dispersive power. 3 physical quantity we are defining. Angular dispersion. See here. Here are so many types of colors are there. What we are calling, one is nothing but red, second one is orange, and third one is yellow, next green, blue, indigo and violet. Are you following? See here. Now I can define angle of deviation for each colors. See here, this incident ray produce. If angle between incident ray and this red light we are calling angle of deviation. Similarly for orange color, how to define this? I can define for orange color. So this is represented by what value? Del O. Similarly for what color? I can define for yellow color. Then again I can define for green color. Again you can define for blue color. Again you can define for what color? Indigo color, like this. Later, see here, shall I take here? I can take it is what value? This I can take red color. This I can take del R value. Then what about this one? This I can call del O. This I can call del Y. This I can call what value? Del Z, like this. For so many colors you can define angle of deviation. See here. Question is, how to define angular dispersion? Angular dispersion is the difference between angle of deviation of any 2 colors. Difference between angle of deviation of any 2 color, that we are calling angular dispersion. For example, for red color, how much angle of deviation? Del R is the angle of deviation. For violet color, how much angle of deviation? Del V is the angle of deviation. See here, how to define angular dispersion? Angular dispersion. Angular dispersion. Angular dispersion. Angular dispersion is a deviation produced by any 2 colors. Deviation produced by any 2. I need to mean either you can take violet and red, you can take violet and indigo, you can take indigo and blue, you can take difference between blue and green, like this. I mean difference between angular deviation of any 2 color, that we are calling angular dispersion. Similarly, mean deviation. If you take the mean of deviation of all the colors, mean deviation of all colors, that we are calling mean deviation. Or simply, whatever deviation produced by yellow color, that we are calling mean deviation. Because if you take deviation of all the colors, angular deviation of the all colors, that is equal to deviation produced by yellow color. So that mean deviation is nothing but the deviation produced by yellow color. Look at me. See here, I can define mean deviation is what? Mean deviation I can define in what way? Mean deviation is equal to how much? Mean deviation is equal to delta. Delta is equal to what value? That is del R plus del V divided by 2. How it is? The deviation produced by yellow color or the deviation, mean deviation of all the colors, This physical quantity I can define mean deviation. Similarly, one more physical quantity I can define, that I can call dispersive power. How can I define dispersive power? Look at me. I can define dispersive power. Dispersive power is simply the ratio of angular dispersion to mean deviation. Ratio of angular dispersion to mean deviation. See here. For angular dispersion between any two color, I mean for violet and red, what is the angular dispersion? What is actually angular dispersion? Del angular dispersion is equal to del V minus del R. And what is mean deviation? Mean deviation is equal to deviation produced by yellow color. How to define dispersive power? Dispersive power simply the ratio of angular dispersion to mean deviation, that physical quantity I can call dispersive power. This is concerned to dispersion of the light. But when white light incident on the prism, 7 types of colors are obtained. Not only on the prism. Similarly, when your white light is incident on the water droplet, there also 7 types of colors are observed. I mean, that we will see the concept of rainbow. See here. Now let us see rainbow, how the rainbow can appear, what are types of rainbow, that we will see in detail. Look at me. See here. Next concept is rainbow. How rainbow can be obtained, that we will see now in detail. Look at me, students. Our next concept is rainbow. Generally, the rainbow occurs during rainfall or after rainfall. How it is? The optical phenomena appeared due to refraction, total internal reflection and dispersion of the light, that we are calling rainbow. Or simply, rainbow is the spectrum of light in the form of bows obtained during rainfall or after rainfall when the sun is shining on opposite side. This phenomena we are calling rainbow. How it is? I can define rainbow like this. See here, the optical phenomena or the band of colors. The band of colors. Band of colors. Band of colors obtained in the form of bows, in the form of bows during rainfall or after rainfall. During rainfall or after rainfall. This we are calling rainbow. Actually, this rainbow is due to combined effect of dispersion, refraction and total internal reflection. I mean, during rainfall or after rainfall, 7 types of band colors, 7 types of colors obtained on the sky, that phenomena we are calling rainbow. Generally, during rainfall or after rainfall, the band of colors are obtained across the sky, that we are calling rainbow. This rainbow mainly consists of 7 colors depending on types of colors, I mean depending on band of colors obtained. The rainbow again classified into 2 categories, one we are calling primary rainbow, second one we are calling secondary rainbow. Let us discuss primary rainbow and secondary rainbow, how primary rainbow can be obtained and how secondary rainbow can be obtained, that we will see now. Look at it. See here. Now first we will see primary rainbow. Primary rainbow. How this rainbow can be obtained? Look at it. During rainfall or after rainfall, consider so many water droplets are available on the sky. We know that the water droplet, it is act as a prism always. Because whenever white light incident on the prism, how many types of colors are obtained? 7 types of colors are obtained. 7 types of colors obtained, that we are calling what? Spectrum. In the form of Ibs or in the form of 7 colors. Now look at me. Consider in the sky any one water droplet is available. I can take this nothing but water droplet available in the sky. See here, shall I discuss this primary rainbow? Now we'll discuss primary rainbow. See here, consider in the sky any one water droplet available. I can take this nothing but water droplet available in the sky, right? Now the white light incident on the water droplet from top of the water droplet. Look at me, how it is. I can take this nothing but one ray of light or narrow beam of light incident on the water droplet. When white light incident on the prism, similarly white light incident on the water droplet, 7 types of colors are obtained. See here, which is least deviated? We can call red light is least deviated and violet light is most deviated. Right around this, look at me. I can take this nothing but red light and what are calling this is white light. In between red and violet, how many types of colors are there? Again, 5 types of colors are there that we are calling VIBs or indigo, blue, green, yellow, orange and red. Right. Now, whenever the ray of light incident at this point, always angle of incident greater than critical angle. Angle of incident greater than critical angle. See here. At this point, angle of incident greater than critical angle, so that again this light is completely reflected in the same medium. Completely reflected in the same medium. What I can call this light, what I can call this light is nothing but red light. Again, wherever white light incident at this point, again angle of incident greater than critical angle, so that how this light can reflected back in the medium, this light can reflected back in this medium, I can call this is what? Violet light. Are you following this? Now, here what happens? The ray of light incident at this point, here dispersion takes place and refraction takes place. Dispersion takes place and refraction takes place. Again here, when ray of light incident at this point, ray of light bounce back in the same medium. So here what happens? Total internal reflection possible. Right? I mean, refraction, dispersion takes place here and here total internal reflection takes place. But again, whenever this violet light incident at this point, this violet light can comes like this. Right? See here, this violet light, how it comes? It can comes like this. And how the red light can comes? Now the red light can comes like this. Look at me. This is comes like this. Right now, in this direction. In this direction red light comes, in this direction violet light comes. See here. Here how many types of refraction possible and how many types of total internal reflection possible. At this point dispersion takes place and refraction takes place. Similarly, at this point refraction takes place. But what about here? Here total internal reflection takes place. I mean, the primary rainbow is obtained due to 2 refraction and 1 total internal reflection. Due to 2 refraction and 1 total internal reflection. Look at me. What I can call this is nothing but red light. This what they are calling violet light. See here, and what are calling this is nothing but ground. I can take this nothing but the ground. So here this red light is most deviated and what about this violet light? It is nothing but least deviated. I mean here more angle available. Here more angle available. Say around it is say it is 50 degree or around it is 40 degree. Right. Now on the ground any observer stands and sees this refracted rays. See here. On this ground consider is the observer stands. Look at me, what I can take. See here. So on this ground observer stand, he is the observer. This observer sees the refracted rays. When observer sees refracted rays, how they can come? Look at me. When this observer sees this refracted ray, how it meets? It can meets like this. So this is nothing but what? Violet light. Similarly, when this refracted ray sees by this observer, which one is? This is the red light. How it comes? It must comes like this. So what are calling this? This we are calling red light. In between red and violet, how many types of colors are there? Again 5 colors are there. That is available in the form of VIBs or like this. Here primary rainbow, how it is appeared? primary rainbow appeared due to 2 refraction and 1 total internal reflection. And here band of 7 colors are obtained. Band of 7 colors, how it is? So in the inner edge, white color is observed. In the outer edge, red color is observed. See here how it is? In the inner edge, violet color is observed, and in the outer edge, red color is observed. So that I can differentiate this primary rainbow. Primary rainbow appeared whenever ray of light coming from top of the water droplet, and it appeared due to 2 refraction and 1 total internal reflection. One thing. Second one is what? In the inner edge, violet light is appeared, and in the outer edge, red color is appeared. And during primary rainbow, the red color has most angle of deviation and violet light has less angle of deviation. Remember this. Now, let us discuss how secondary rainbow can appear. How secondary rainbow can appear, and by what refraction it takes place, and but how many total internal reflection takes place, that we'll see. Look at me. Now let us discuss this, nothing but, and what is condition for rainbow, that we'll see later. Look at me. How the light is coming? Light is coming like this. Light is coming like this. Right or wrong? So how the rainbow can appear? At this point rainbow can appear. Remember this point. But taking primary and secondary, I will discuss what is condition for rainbow. To appear the rainbow, what is the condition, that we'll see later. Look at me. Now I can take how secondary rainbow can appear. Look at me. This is nothing but again water droplet that is available in the sky. Look at me. For my convenience, I will take here. This is water droplet available in the sky. Right? Always the water droplet act as a prism. Now, ray of light not only coming from top of the water droplet, ray of light also coming from bottom of the water droplet. Look at me here. See here. This is what now? Now we'll discuss secondary rainbow. See here. We'll discuss secondary rainbow. Right. Now, consider the ray of light which is coming from bottom of the water droplet like this. Right? When white light is incident at this point, it disperse and refract. Disperse means this I can call red light, and what about this one? I can call violet light. This I can call red, and this I can call violet, because red light is least deviated and violet color is most deviated. But at this point, angle of incident greater than critical angle. At this point, angle of incident greater than critical angle. So that total internal reflection possible. How it is? At this point, always angle of incident greater than critical angle. So that here total internal reflection can possible, and red light comes here. Are you following? Similarly, at this point also total internal reflection possible. This I can call what value? This I can call violet color. Right? Similarly, again at this point, again angle of incident greater than critical angle, again total internal reflection possible. See here how it is. Now red light comes like this. Again at this point total internal reflection possible. What I can call? See here. What I can call? This is what value? Violet light. Right around this. Again, whenever at this point, again refraction takes place. How it is? Now red light comes like this. Then what about this? Violet light comes like this. Right around. What I can call? So this I can call violet light. What about this? Red light. Then question is, during how many refraction and how many total internal reflection possible? Look at here. Whenever white light incident at this point, here what happened? Dispersion takes place and refraction takes place. Dispersion takes place and refraction takes place. Similarly, here also refraction takes place. I mean, secondary rainbow is appear due to refraction. Similarly, see here, when ray of light incident at this point and at this point, here light can bounce back in the same medium, and here also light can bounce back in the same medium. Light can bounce back in the same medium. How it is? Here also bounce back, here also bounce back. Similarly, same takes place here also. I mean, secondary rainbow is appeared due to 2 total internal reflection and due to 2 refraction. See here. Here also refraction takes place, here also refraction takes place, but here, in this case, total internal reflection possible, in this case, total internal reflection possible. Now, which color is appeared on the inner edge and which color is appeared on the outer edge, that we'll see now. Look at here. Now, how the refracted ray comes, like this refracted ray comes, is the observer stands here, and look the refracted ray, right around. When observer sees how this violet light can go, this violet light can go like this I can call violet color. And what about this red light? This red light can come and it comes here. In between violet and red, again how many colors are there? 5 colors are there, like this. So, see here, this is what? Band of 7 colors. Look at it. In this case, inner edge, which color is appeared? Violet color appeared. In this case, inner edge, which color is appeared? I can take, this is what? Red color. And what about outer edge? In the outer edge, violet color is appeared. So, main difference between primary rainbow and secondary rainbow. In primary rainbow, 2 refraction possible, 1 total internal reflection possible, one thing. In secondary rainbow, 2 refraction possible and 2 total internal reflection possible, right? One thing. Second one. During primary rainbow, inner edge violet color appeared and outer edge red color appeared. But in the secondary rainbow, inner edge red color appeared and outer edge violet color is appeared. And primary rainbow is formed whenever the ray of light incident on the top of the water droplet. Similarly, secondary rainbow can appear when ray of light coming from bottom of the water droplet. These are what main difference between primary rainbow and secondary rainbow. But to appear primary rainbow and secondary rainbow, what is condition? Look at me. How the ray of light come? Ray of light can comes like this or the ray of light can comes like this. See the observer stands here. See here. Water droplet is available here and light is coming from back side. I mean, sun should be shining in up one side and water droplet should be in other side, then only the rainbow can appear. I mean, when sun is shining in back side and water droplets available in front side, then only rainbow can appear. To appear the rainbow, sun should be shining in one side and water droplet should be in opposite side, then only the rainbow can appear. This is main condition for appearance of the rainbow. But other than this rainbow, sky is appeared to be blue and sky is appeared to be reddish during sunrise and sunset. Initially we will see how the sky can appear to be blue. The blue color of the sky, how it is? We know that in the atmosphere so many gas molecules are there, mainly nitrogen and hydrogen. Rayleigh says that the intensity of scattering light inversely proportional to 4th power of wavelength. See here, what Rayleigh says that the intensity of the scattering light inversely proportional to 4th power of wavelength of light is. See here, light can scatter only for one condition. When atmosphere contains so many gas molecules, if the size of the molecule is very small as compared to wavelength of light used, then only light can scatter. For what condition? If the size of the gas molecule very smaller as compared to wavelength of the light used, then only light can scatter. See here, the wavelength of blue light is comparable to the size of the nitrogen and oxygen. The size of the nitrogen and oxygen molecule is comparable with the wavelength of light used. I mean, the wavelength of the blue color is comparable with the nitrogen and oxygen, so that the blue color is more scattered by nitrogen and oxygen. I mean, other than all colors, the wavelength of the blue color is comparable to the molecules, particles of the nitrogen and oxygen, so that the blue color is most scattered by nitrogen and oxygen. Due to this reason, the sky is appeared to be blue. One thing. During sunshine and sunset, the sky is appeared to be red because only one reason. We know that. How many types of colors are there? 7 types of colors are there. What are the king? That is available in the form of Vibzior. See here. This violet color has the least wavelength. And the red color has the highest wavelength. Remember this point. During sunrise and sunset, this wavelength color has a longer wavelength and travel for a longer distance during at the horizon. At the horizon of the earth, this red color traveling the longer distance, so that during sunrise and sunset, this first color is reaches to the earth, that we are calling red, and remaining all the colors are scattered. How it is? During sunrise and sunset, which color is first comes? The red color is first comes because it travels for a longer distance. So during sunrise and sunset, the first color which reaches to the earth, that only the red. So that during sunrise and sunset, the skies appear to be reddish in nature. This is concerned to the dispersion of the light, primary rainbow, secondary rainbow, and appearance of the sky during sunrise and sunset as a red. Similarly, appearance of the sky as a blue in color. The further concept we will see in the next session. Thank you.